Hello and welcome to this video. In this video, we will learn about closures. But before we get started with closures, I would like to refresh the concept of borrowing in Rust. So suppose we have a function and we pass a value to it. Now, Rust usually either moves the value or it borrows the value. So borrowing is of two types. One is mutable and another is immutable. And move is simply move. The ownership of the variable is transferred. So in case of immutable reference, the value which is passed to a function cannot be modified. But in case of a mutable reference, the value can be modified. Now, there is something very important in this is that you can have as many immutable borrow of a variable as you want, but the mutable borrow can be taken by only one function. This is very important when you will deal with multi-threaded programming because only one threaded can take mutable, can mutably borrow one variable while other threads will have to immutably borrow the variable. The reason is that when more than one thread, don't worry if you don't understand threads yet, but if you already know about threads, then this will help. So if more than one thread want to modify a variable, then they have to take a lock. And the problem with lock is that once a thread takes a lock, for the duration of the lock, other threads which have to act on that piece of critical section or the code which is being locked on, other threads will have to wait. Now consider a multi-threaded program with large number of threads and lots of threads are waiting on a particular lock. So that brings down the efficiency. So for a lockless mechanism, it is essential that only one thread takes mutable borrow. So since only one thread can modify, other threads can't modify it. So there is no need of taking a lock. And in case of immutable borrow, since the value is only being read, any thread can read as much as they want. So that solves the problem of locking in the borrowing. Now consider this code which we had, fizzbuzz. So here, suppose we declare a vector v vector and we say 1, 2, 3. Okay. And we pass this to fizzbuzz and we pass it by value. And if you put it here, that I32, and if you then try to print it, then you'll see something interesting. So if you mouse over this, you see it says use of moved value v. So when you pass the vector v to the function, the value is moved. So the fizzbuzz2 function cannot access this value v. The other thing is that it's in a loop, so it will be a problem. It can move only once. So in the first call, it will be moved. You cannot call it again in this. Okay. So this is the movement of value, move of a value, not movement, move of a value in Rust. A function can take ownership of a variable, and borrow is what we have seen. For example, this n is being borrowed here. Okay, but v is not. For example, if you want to see print ln, and then if you see, you can print n, but not v. You cannot use v, but you can use n. So n is being borrowed, but v is being moved. So with that out of the way, let's go back to our closure thing. So what is a closure? You can think of closure in the sense of an anonymous function. In closures, both the input and the output, that is the arguments to the closure and the return type of the closure, both are inferred. You don't need to specify the types, but you can specify the types if you want. The difference between a function and closure is that a function cannot capture its environment, but a closure can. For example, consider this outer var 42, and we have this function. The name itself is function. Okay, so this function cannot access this outer variable. Okay, you see, can't capture dynamic environment enough f in fn item. So it suggests also use the closure instead. Okay. So the typical syntax of a closure is something like this. Say you name the closure. Okay. Say you name the closure. Then you have this syntax, and then for multi-line you have to give braces. Okay. For single line you can leave it, and then you write something here. For example, you can pass a value x and you can do something with x plus 5 or something. So here we have outer var and we have this closure. It takes an input I of type i32 and returns i32 also, and adds outer var to this I. So this is an annotated type of closure where we specify the data type of the variable, but in the inferred type, you don't need to do this. You don't even need this brace. So you can simply say I plus outer var. So when we call a closure with annotated 1, this I becomes 1 and 42 is added. It becomes 43 in both the cases. Okay. Now, important thing is that once the type is inferred, that is in the first call, obviously the type will be inferred when you call it first time. Then the type of I and the return type will be set. Once it is inferred, you cannot change it again. For example, if you want to pass an I64 here, okay, it won't work because it is, this is inferred, inferred, the second one. This type, the type of I is already inferred as I32, but now we are trying to pass I64, so it won't work. Okay, that is something you have to take care of. And then the last example is that we have a closure, it takes no arguments and returns I32, the return type is inferred here. It was inferred here also. So it will print 1. So if you want to see this in action, let me go to closure 1 and run it, cargo run. So you see the annotated printed 43, inferred printed 43, and returning 1 printed 1. So that is the basic of closure. Now we look at a bit more involved function. Now closure, excuse me, the closure can capture values in or take input in 3 ways. One is by value, another is by immutable reference, and last by immutable reference. So see this example, we have a string color, okay, and we print color here. So this capturing of color will be by immutable borrow because it does not modify. So since it does not modify, it sees that I don't modify, so I don't need a mutable reference. I need only immutable reference. So it does that. And when you call, it will print the color, that is green. Now, color we can borrow again. Okay. Print is again called here. So at this moment, there are 2 borrows of color, one to the borrow, one to the closure. So no problem. But once you move the color, you assign it to a different variable, then this color, the data will be dropped. It is no longer a valid variable. You can't use it. It is moved. Okay. So once you do this, you cannot call print. If you call print here, it will be a problem. See, you will see here. So it says cannot move out of color because it is borrowed. So print has borrowed it and it continues to borrow. So this movement is not allowed. So if you don't, uh, at this moment, the borrowing ends. Here the borrow ends. And then you can move the color. Remember that a borrowed value you cannot move. And you cannot take mutable reference of that. Sorry, I mean to say you can take only one mutable reference of that. Now consider this mutable variable count. Okay. So here, since this count is mutable, the borrow will be of type mutable reference. So we modify count here. You see, we modify count. We make count 1 in INC closer. So since count is being modified, it has to be taken as a mutable borrow. And then you print count, that is 1. So it will print 1. And now since it has captured the value, it will print 2. This ink won't print 2 here. The count becomes 1 here, and here it will become 2. But if you try to borrow again, it's a problem. You cannot, because immutable, because it is borrows as immutable. So immutable borrow you cannot happen. Okay. Now, as I said, there can be many immutable borrows, but only one mutable borrow. You cannot have multiple mutable borrows. So ink will print here too. And then we reborrow here, and this will work because after this, ink is no longer accessing the count variable. Now consider a movable variable. It's a pointer. Box is a pointer. You can think in terms of new pointer in C++ or Java. So it's a pointer to 3, an int. And then we take it, we consume in the consume means we drop the value movable in consume closure. That means since we are dropping it here, the internal data related to this pointer has to be removed and the pointer will no longer be accessible. So that's why here a move will occur. Okay. And this you can call only once. If you try to call it again, it will try to drop. It will try to drop it again. So Rust compiler will see, no, this is not possible. This value is moved once, you cannot move it again. You will see, if I comment this, you see use of moved value consume, value used here after move. So this value is moved. You cannot move any, sorry, this value is dropped. So you cannot free a pointer twice. So that's the 3 ways you can do a closure. One is by value, one is by mutable reference, one is by mutable reference. Plus you can move the values. So moving is something different. Okay. Now if you want to see it in run, so let me go to closure 2 and we run this. So it prints color twice, and then 1, and then 2, and then the movable value 3. So as you will see, Rust programming closures are used quite liberally. You will see many uses of closures in library functions or in frameworks. If you study their code, you will find that they make a lot of uses of closures. So it is important to understand this concept, and if you are not clear, I would request you to watch the video again and read the documentation, probably on doc.rustlang.org, or read any other book which you want. Or you can go to Rustlang forum and ask questions there, or you can ask me also using the comment box. So I hope that this video was useful to you. And this is not the end of closures. We will see more of closures. So we can pass the closures to a function. We can return closures from a function. So all those things we will see tomorrow. I don't want to cover too much in one video. So I'll see you in the next video with the closures continued. Thanks a lot for watching. Happy programming.